Hey, welcome back, trig students, trig pre-calc, I should say. Um, Today we're looking at law of sines. We're almost done with all of the trig stuff. We just have a couple more lessons to do, a couple more assignments. Law of sines is something that's super important because this whole time we've been talking about triangles and stuff. We've only been talking about how to solve right triangles. For today's and tomorrow's lessons, the law of sines and law of cosines, these are really helpful because you don't need uh, a right triangle in order to solve these triangles. So it's kind of neat. Um, Also, law of sines versus law of cosines. The law of sines is useful if we have a pair of opposite sides of the angles. As you'll see, for the most part, law of sines is pretty straightforward. The examples at the end get a little bit complicated. We're not going to worry about those too much, but I did want to visit with them just to make sure that you understand that law of sines is not always applicable or not always the best way to do it, because we get cases where we have different solutions. One thing to note is if we look at this triangle here, just note that each of the angles, so if we look at angle capital C, it's always going to be across from the side, the corresponding side, which is little c. Same with little b and big B, and little a and big A. So it's very important to note that when we're setting this stuff up, that each of those little letters, so the sides, are opposite the corresponding angles. Okay, so when we set these triangles up, we are operating under the assumption that the sides are labeled corresponding to the angles and they're opposite each other. Okay, so we're looking at a right triangle here. Notice that we're being given two angles, the 40 degrees and the 60 degrees, and we're giving one side. So what we want to do is we want to start off this. Well, first of all, solve the triangle means they want us to find all the missing angles and sides. So we're trying to find little c, big C, and little b. So what we want to do here first is we want to identify the one pair of corresponding opposite sides and angles. So we have this 4. Let me change colors here. So we got this 4 and this 40. And then we're going to look at the other information that we have. Okay, we have this 60 degree and we're trying to find B. All right, so what we're going to do is if we go back here, we know that the law of sines states that sine A over little a is the same thing as sine B over little b, which is the same thing as sine big C over little c. So we're going to start this off by saying, okay, if I'm looking at this pair of sides and angles, then I just have to fill in sine 40 over 4, right? That's the opposite side that matches up with the angle, is equal to sine 60, right? I'm looking at these ones. Sine 60 over B. So what we're trying to do here is we're trying to set up, we're trying to fill in 3 of the missing pieces to our puzzle so that we can find our B here. Right, so all we have to do is solve this for B. So when we have a proportion like this, we're going to cross multiply. So B times sine 40 is equal to 4 sine 60. And then in order for us to find B, we're just going to algebra a little bit. I'm going to divide by sine 40 so that we can cancel it out. And then we know what B is. So we're going to do this on our calculators. 4 sine 60 over sine 40. Okay, so we're going to make sure we're measuring in degrees. And we're going to say 4 sine 60 divided by sine 40 equals, and we get 5 point, I'm not sure if it's asking it, let's round to the nearest 10, so 5.3, 5.4. Okay, so 5.4. Okay, now we're trying to find big C and little c. So this one we're finding B. Okay, the next thing we want to do, and we could have done this first. It doesn't really matter the order in this case. But what we do know about the triangle is any triangle, the sum of the angles inside the interior angles is going to add up to 180. So if we have 40 and 60, then we can definitely find the C. We're just going to do 180 minus 40 minus 60, and that should give us our C. We should probably say angle C. All right, so 180 minus 40 is 140. 140 minus 60 is 80. So we know that C is 80. And then the last thing we need to find, we found angle C, we found side B. We need to find the last side C here. Okay, and we can set this up again like we did. So we can use the sine 40 over 4 equals, now that we know that the angle is 80, right? We can say sine 80 because we're trying to find the opposite side, right? Over C. It's going to solve a lot like we did in that first one. So we're going to do cross multiplication. C sine 40 equals 4 sine 80. And then we divide by sine 40. So C is going to be equal to, let's get that, 4 sine 80 divided by sine 40. 4 sine 80 divided by sine 40, 6.1. Okay, so pretty useful, not too hard. We just have to deal with proportions and a little bit of algebra, and we should be able to find all of our sides. Okay, let's look at another type. All right, so this one we have a skinnier looking triangle. But what we can do from this one, well, notice that we don't have any opposite side and angle pairs, right? So we have 15 and B. That's not telling us the side length. We have 35 degrees in A. That's not telling us our side length. Then we have C and 5. So in this case, what we want to do is we want to use that first property first, where we figure out all the angles of the triangles. So we're trying to find angle C. And we know that we can find angle C because we have two angles, and the total, the sum of the angles need to be 180. So we're going to do 180 minus 15 minus 35, and that's going to give us our angle C. So 180 minus 15 is 165, minus 35 is 130. You can write that in. Now we have a corresponding, an opposite side and angle. So we can set that up. We can say, so for part 2, you can find A or B depending on how you want to do it. It doesn't matter which one you start with first in this case. So we're going to just set it up. So sine 130 over 5, right? The 130 and 5 are opposite sides and angles, is equal to, let's do A because it's alphabetical. So the, excuse me, the angle across A is 35. We're going to go ahead and solve this exactly like we did the other cases. So 5 sine 35 equals A sine 130. We're going to divide by sine 130. And then we get A. So A is going to be equal to 5 sine 35 over sine 130. 5 sine 35 divided by sine 130. Make sure you close these parentheses too, yeah? If you don't do it, the calculators are not very good sometimes at order of operations and stuff like that and understanding what you want to do. So it might give you the wrong answer. All right, so for this one, we get 3.7. So we know that A is 3.7. And then we'll find B, the last missing side. So we can set up the sine 130 again over 5 is going to be equal to 15 is the angle across B. So sine 15 over B, cross multiply again. And then divide. You guys might be able to do this without writing all the steps down already because we understand how this stuff works. So B is going to be equal to 5 sine 15 over sine 130. 5 sine 15 divided by sine 130. And we get 1.7. Which kind of makes sense, right? Like the 5 is the hypotenuse. It's across from the biggest angle. A is the next longest side. That's 3.7. Seems reasonable. It's shorter than the hypotenuse, but pretty long still. And then B is obviously the shortest side. It's across from the shortest angle, and that's the smallest or the shortest length. Okay? So pretty straightforward. The process of it is pretty same as the one we did before, except for this first part where we wanted to find the missing angle first. So let's look at some cases where it gets a little bit weird. All right, so anytime we have side-side angle, and those of you who have geometry and remember, side-side angle is not one of the theorems that prove congruence. Wow, well. It's not one of the ones that prove congruence, and it's weird because sometimes it'll work and we'll have one solution, sometimes we'll have multiple solutions, sometimes we might not have a solution. And what side-side angle means is that we know that two sides that are next to each other, and then the angle is outside of those two sides. So it's not in the middle of those two sides, it's outside the two sides. So in this case, we have the 2 and the 3, and we have the 40 degrees outside. So when we have triangles like this, the law of sines works, but not all the time. So let's kind of look at how this one would work. So we definitely have an opposite side and angle, right? So we can set this up as sine 40 over 3 is equal to, now because we know what the 2 is, let's do 2 and B, right? So we're going to say that we have sine B over 2. All right, so let's start doing some algebra here. We just really have to multiply by 2 here to get rid of the 2. So we have 2 sine 40 over 3 equals sine B. Now, to get to the B, though, because we're trying to find an angle, remember, if we're trying to undo sine, we sine inverse, and I didn't leave room here, but sine inverse the right side. Right, so that we get B, and we're just taking the sine inverse of the whole left side. So let me write this down so I don't mess it up. Sine inverse 2 sine 40 over 3. Okay. So what we want to do here, back at our calculators, we're going to do, remember we have to shift this. We're in degrees, so that's good. Where's my shift button? If I hold it down? Oh, that's not gonna work. Oh, inverse. There we go. So sine inverse, and in our parentheses, I'm gonna put 2 sine 40, close that parentheses, divided by 3, and then close the bigger parentheses. So it's taking the sine inverse of that whole parentheses. We're gonna have hit equals, and we're gonna say 25 point, we'll round the 3 up to 4. So 25.4 degrees, because we're talking about an angle. So 25.4 degrees. Right, so we solved it a little bit different because now we're trying to find an angle. We're not given two angles. If you want at this point, and we should probably do it, is let's find the third angle, angle C. So angle C We already know one of the angles is 40. We know the other angle now is 25.4. So C is going to be equal to 180 minus 40 is 140. Minus 25.4 is 114.6. Okay, so we got our last angle. And now let's use that to find our little c, our side c. So we're going to say that sine, I like to use the one that we started with. So sine 40 over 3, because it's not going to be rounded, right? It's already numbers that we've been given, so it's good to go back to them. Is equal to sine 114.6 degrees divided by c. Okay, now that we have the angles, and we're not looking for the angles anymore, we're looking for the side, it's going to solve like we did before. So we have c times, right, we're going to cross multiply sine 60 is equal to 3 times sine 114.6 and then we just have to divide by sine 60 because we're trying to solve for c. Okay, so 3 sine 114.6 over sine 60. 3 sine 114.6 divided by sine 60. 3.1. Okay, so 3.1. Okay, makes sense. C is the biggest angle, so the side C should probably be the longest. Well, it should be the longest side. And then 2 is across the smallest angle. 3 is across the medium angle, which is 40. So it all looks pretty good. Okay, so just a brief check just to make sure our numbers that we get make sense. All right, so this is a good one. It solved pretty easily. There was no weirdness going on. But if we take a look at the next one, so say we've been given that A is 35 degrees, little a is 6, and B is 8. So I kind of drew out what this might look like. The problem with this one, excuse me, is that if we have our 8, right, it's just one of the sides, our angle 35, right, and then we know that the opposite side is 6. Because of the way triangles are, there's 2 separate triangles that we could have with an opposite side of our angle A being 6. So one of them is, let's draw this highlighted in red, or let's outline it, right? So is this triangle here, right? So as long as that side is 6, then we're good. That's labeled 6. Now we could draw another triangle with the same exact dimensions that we know, but it'll look different. So the 8 doesn't change, the angle 35 doesn't change, but now look, this could also be a 6 here, and we'd have 2 triangles that fit the description of this triangle. So this is where we kind of get messed up. So let's kind of solve for each triangle here. So let's do the red one first. All right, so notice this one, this angle here across from the 8 is obtuse. So it's going to be bigger than 180. All right, so let's kind of start setting this up. We know that the 35 and the 6 are across from each other. Sine 35 over 6 is equal to sine, we don't know what this is. It's going to be B, right? Capital B for angle B over 8. Let's see what happens here. So let's kind of start solving this a little bit. So we're going to have cross multiply 8 sine 35 is equal to 6 sine B. And we're going to divide by our 6. And then remember, we're going to take our sine inverse. So we're going to sine inverse. Because, oops, that's not sine. Sine inverse. Because we want to have the signs cancel. And we want to find our B. So then we're going to do on our calculator again. Sine inverse. And we have 8 sine 35 over 6. So 8 sine 35 divided by 6. And we get about 49.9. So 49.9. Okay, so what we're looking at here is 49.9. That doesn't describe that angle. Right, because we said that in the beginning, if we're looking at that angle, it's obtuse. So this number that we're getting here is actually this value here, 49.9. In order to find this angle here, we're just gonna find the what word am I looking for? The supplement to it. So all we have to do is do 180 minus 49.9, and that should give us our angle. So 180 minus 49.9 is equal to 130.1. Okay, so this one, if we're talking about just a smaller triangle, then our B that we're going to use is 130.1. Now we can find the last angle, right? So angle C, angle C is going to be 180 minus the 35 that we're being given, minus 130.1. So angle C is going to be 180 minus 35 minus 130.1 is 14.9 degrees. Okay, so we know our B, we know our C, and then we can use our law of sines to find our missing side, and that would be side C, right? So we're gonna say sine angle C is 14.9 over C is equal to sine 35 over 6. You guys go ahead and solve that. We know that we're going to have 6 sine 14.9 over sine 35. I'm not going to show the work. You guys can refer back to the other ones. But C is going to be equal to then 6 times 14.6 sine 14.9 divided by sine 35. 6 sine 14.9. Oops, that's not 14.9. 14.9 divided by sine 35 equals 2.7. Okay, now if we were trying to find the other one, then we got to solve the other triangle, right? So let's do that in orange. So one thing we found already was the B for that triangle. So B is going to be equal to 49.9. The same thing for C, right? We're going to take that 180 minus the 35 we were given minus 49.9. And that should give us a different C, right? So 180 minus 35 minus 49.9 equals 95.1. And then we'd use that C now to solve the missing side C which now should be a lot longer. So let's do sine 35 over 6 equals sine 95.1 over c. And when we do all our work there, we should end up with 6 sine 95.1, 6 sine 95.1 divided by sine 35, which is 10.4. Right, so this is two solutions, so it gets a little tricky. Yeah, so just be very careful when we do this. Yeah, you could have two solutions. Not something super important to remember as you move forward, but I do want to talk about it because we're here. Okay, and the last one is actually the easiest one. There's no solution, so you can draw it out or not draw it out if you want to, but we can just start setting this up. So if we set this up, we know our C and our C are across from each other, so we can say sine 50 over 1 is equal to, and we can say sine capital A, right, because we want to find the corresponding angle to that side, over 2. Now let's see why this is not going to come out. If we multiply 2 and sine 50 and sine A, so then 2 sine 50 equals, well, we could say 1 sine A, but 1 times anything is itself, so let's just say sine A. We're trying to get this to this A again, so at this point we're going to sine inverse both sides, right? Going back to like a chapter or two ago, how to undo our sines and sine inverses. So they cancel. And here's the weird thing. So if we plug in sine inverse of 2 sine 50, let's see what we get. Sine inverse of 2 sine 50 equals, oh, there's an error. Okay, so that automatically tells us no solution. And let's kind of look at why. So if we do 2 sine 50 first, right? So let's do 2 sine 50, which is what's inside. We get 1.53. Well, we could say 1.5. So this thing is the same thing as 1.5, approximately. Now, remember the sine inverse is asking us, all right, find the angle where the sine is going to be this number inside 1.5. So think about the unit circle, right? Do we ever have a sine? Remember, our sine is our y value. Our y value. Do we ever have a sine that's greater than 1? No, right? The biggest sine or cosine we could get, it would be 1. So if it's asking us to find an angle where it's bigger than 1, then there's no place that we can find it. Therefore, no solution. And if we drew out this triangle, we'd see that is disproportionate, because there's no way we can have a side that's twice as long as one of the other sides and have our angle be 50 degrees. So like if we drew a 50-degree angle here, I don't know if that's 50 degrees. I think that's less than 50 degrees. But anyway, so if this were 50, there's no way we can have a side that's half as long as the longest side and still have a triangle. Like, it won't connect. There's going to be a gap. So just because they give us dimensions doesn't mean it always makes a triangle. All right, so just be aware. There's only going to be like 2 or 3 of the ones that we just did with the side angles. I don't want to overwhelm you with that because it's not super important. It's just more important for you to be aware that it could happen. And then most of the work is going to be like the first 2 examples where it's pretty straightforward. We have an opposite side and an angle, or we have to find the opposite side. Oops. Or like this solution here, we have to find the missing angle first, which is pretty easy. We just subtract it from 180 and then go ahead and set up our different law of sines and cosines.